Suppose that in the 2026 QAMT Problem Solving Competition, you get given this problem. Alice and Bob play a game. Alice picks a natural number from 1 to 2026 secretly. Bob may ask Alice yes or no questions of the form, is your number greater than k? For any natural number k he chooses after hearing previous answers. What is the least number of such questions Bob needs to ask to guarantee that he can identify Alice's number? Okay, so let's say that we have n possibilities for Alice's number, right? At the start, we just set n equals to 2026. There are 2026 possibilities. And then Bob asks a question, right? And Alice can answer yes or no. There are two possibilities for the answer. And after hearing this answer, Bob would know whether it's in this yes part or it's in the no part. And in both of these parts, there's altogether n possibilities, right? So maybe there are A different numbers that satisfy this, and B numbers that satisfy this, where A plus B is equal to n. So after asking the question, the number of possibilities for Alice's number reduces from n down to either A or B, depending on Alice's answer. So we want to know how many times Bob needs to ask a question to reduce the number of possibilities down to 1, in which case Bob can guarantee that he can identify Alice's number. So, of course, Alice can always answer in a way such that the number of possibilities is the bigger one out of the two, A and B, right? So, what he can guarantee is that if he tries to make A and B as close as possible, then the number of possibilities is always going to about roughly half after he asks a question. But if maybe A is very big and B is very small, then if Alice answers yes, then the number of possibilities doesn't reduce by very much. So our strategy is just to choose the number that's in the middle of the range where you think Alice's number is going to be. So every question, we can say the number of possibilities halves. For example, we start with 2026 possibilities at the start. And then maybe Bob can ask, is your number greater than 1013? So this is greater than 1013. This is not greater than 1013. And each of these cases has 1013 possibilities. And we've narrowed down our range to half. So for example, if the answer was greater than 1013, we've got that. And then after that, we can always split into two groups, yes or no. And the strategy is try to make them as even as we possibly can, right? So maybe we can make one of these 506 and 507. Of course, 1013 is odd, so we can't do much here. Can't make them exactly even. And of course, Alice can answer in such a way that our possibilities narrow down to this bigger number, but that's okay because we can still halve it. We get to what? 253, 254, and we can keep going, right? And eventually, Well, if you see what's going to happen, 127, 64, if we always try and guess the number in the middle of that range, then it would keep halving until we get to 1. And we can see that this 64, this is 2 to the power of 6. So here he's asked one question to get to 1013, two questions, 3, 4, 5. So after 5 questions, Bob is able to narrow down the number of possibilities to 64, and that is 2 to the power of 6. So that means he has to ask another 6 questions to get it down because the power of 2 reduces by 1 each time. The next question would be 32, which is 2 to the power of 5, and then 16, which is 2 to the power of 4, and so on. So then he needs to ask another 6 questions. So I can just write 6 questions, and then we would get to 1 equals 2 to the power of 0. And when the number of possibilities is 1, then Bob definitely knows what Alice's number is. So that means after 5 questions and 6 more, the answer is going to be 5 plus 6 equals 11. And we are done. And of course, you can see that 2026 is pretty close to 2 to the power of 11. So we need to try and half about 11 times before we can get to 1. So that confirms that we have the right answer.